All right. In today's lesson, I will be doing a few more examples on uh, this definite integral. That's the Riemann sum, the limit of the Riemann sum. So I have a few examples here. The first example is I have a function f of x equals x minus 2 when x is less than 3 and 1 when x is greater than 3. So this is the function. I drew the graph of the function. I did it ahead of time to save some time, video time. So we want to calculate these integrals, okay? Just to remind you, the integral of f of x dx from a to b is actually the limit of some Riemann sum, f of xi star times delta xi from 1 up to n as n approach to infinity. And the delta x is b minus a over n, and f of xi's are elements from each xi's are elements from each subinterval. So this is a shorthand to say this, where we saw that in class that this really means we're trying to find the signed area between the graph and the x-axis. So that's what we will be doing, the areas we're going to calculate, okay, in this session. So the first one is the integral from 0 to 5 of f of x dx. 0 is here, 5 is here. So we're going to calculate, we're going to count the area, okay? So if you see this, this is the area. That's a 2 by 2 triangle. So that gives you 2 times 2 times a half. So the area of this is 2 times 2 times a half. That's 2 square units, but it is negative because it is below the x-axis. So negative 2 plus, here's a half, and here is 1, 2. So that gives me 2.5. So plus 2.5. This is 0.5. So the integral from 0 up to 5 equals this negative area of negative 2 plus this positive area of 2.5, which adds up to 0.5. Okay? B says the integral from 2 to 2. Let me clean this up first. The integral from 2 to 2 of f of x dx. Actually, I'm going to change it from 3 to 3. So if you look at the integral from 3 to 3 of the function, we're trying to find the area from 3 to 3. There is no area. Okay, that means that this integral is 0. The reasoning behind it is if you look at delta x as b minus a over n, this is going to be 3 minus 3 over n, which is 0. So every single delta x is 0. So you're multiplying 0 times stuff. 0 times f of xi star. So you're adding a whole bunch of zeros, which would give you 0. Okay? So anytime you have the integral from a to a of f of x dx, it should be 0. Okay? The next one, so let me put that out here. The integral from a to a of f of x dx is always 0. You start at the same place as you finish at the same place where you started. The next one is the integral from 5 to 3 of f of x dx. It's not from 3 to 5. This is from 5 to 3. We're trying to go backwards from 5 to 3, which would mean that the delta axis will be negative, which will mean that the sum will be negative. So when this happens, the way to do it is you're going to integrate from 3 to 5 and put a minus in front of it. From 3 to 5, the area is 2 units. So that will be negative 2. Okay, so you're doing the integral switch. Anytime you switch the limits, it produces a minus. Okay, let me box this. That's another rule. This rule comes from the delta axis will be negative, so that's why we have a minus. But that's not really, let's not go into the details of it, but that's what we get. Same thing here, from 2 to 0 of f of x dx, we will do the negative of from 0 to 2 of f of x dx. Okay, from 0 to 2 is this area, that's negative 2. So that gives me also negative 2. Negative of negative 2. Which gives me 2. Okay, that's the first example. This example is just to show you how you could do this. Sometimes when we have the same point from a to a, the integral is always 0. Sometimes if we want to switch the top and the bottom of the integral limits, then it'll cost us a minus, whether or not the integral inside is positive or negative. Okay, whether or not the integral in here is negative or positive. Okay, it'll cost us a minus. We have to multiply by minus. In this case, this is positive, so it gives us minus 2. In this case, this is negative, so it gives us plus 2. The 2's are coincidence. All right, let's do another problem. I have to calculate the integral from 2 to 4 of 2x plus 3 dx. Oh, okay, I don't know how to do this. So what I'm going to do is I'm going to try to draw the graph of the function y equals 2x plus 3. Okay, so this is my y-axis. This is going to be my x-axis. And I'm going to work it from 2 to 4. So this is 2 to 4. It's a linear function, okay, with slope of 3. Y-intercept is 2. When x is 2, y is 4. When x is 4, y is 11. 3, 4, 5, 6. I don't have 11, so 2, 3, 4, 5. So I would say this is 11. So that would be 11. When x is 2, y is 4. This is going to be my 4. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. No. When x is 2, y is 7. So 1, 2, 3, 4, 5, 6, 7. Yeah, I wanted to get this right. Okay, so the linear graph looks like that. It's going to be my y equals f of x, okay, which is 2x plus 3. And they want us to integrate from 2 to 4. So all they need is the area from 2 to 4. Okay, this triangle, this guy is 7, so this guy is 4. This is 2. It's not the x scale is not the same as the y scale. So this triangle has area of 2 times 4 times a half. This is 4 square units. Oh, sorry. And this rectangle is 2 by 7. So the area here is 2 times 7. That's 14. So this integral becomes 4 plus 14 equals 18. The reason is we're having all this area positive, we're just adding them up. So my quiz for you is to compute the integral from 1 to 3 of 2x plus 1 dx. Okay, compute this in a piece of paper, scan and submit on Moodle. All right, let's go ahead and do the next example. They want us to integrate square root of 36 plus x squared from 0 to 6. This will be my last example for today. So I want to draw the graph of this function. I did do something similar graph a while back in class. So I'm going to do this. So we're going to need, remember that y must be greater than or equal to 0 because the square roots are always positive. Now square both sides, so you get y squared equals 36 minus x squared. This gives you x squared plus y squared equals 36. Why did I do that? I just brought that x squared over to the left side. This is a circle. It's an equation of a circle. Center is at 0, 0, and radius is 6, square root of 36. So that's a circle. So this being y greater than 0, the whole graph would be, the graph of this function is a semicircle. So let me see if I can draw a circle, a semicircle, above the x-axis. Okay. With radius 6. Let's see, 1, 2, 3, 4, 5. I'm just going to scale it to 6 here. 6 here. 6 here. 6 here. And do a circle of radius 6 units. That's the graph of the function y equals square root of 36 minus x squared. So we want the integral from 0 to 6 of 36 minus x squared dx. 0 is here. So what we're looking for is this area. That's a quarter of the circle. So that will be a quarter of pi r squared. R is 6. That's 36 over 4 times pi. All right. That's 9 pi. And that's the integral from 0 to 6 of square root of 36 minus x squared. I want to give you a little exercise here. Okay, just do it on a piece of paper and bring it to class and you show it to me. Okay, compute the integral from 3 to 4 of square root of 1 minus x minus 3 squared dx. That's a little exercise that I want you to try at home before you come to class. So it's kind of similar to what we have here. Okay, all right. Well, have a wonderful break. Have a nice Thanksgiving break. I will see you guys on Monday after break.